Great. So welcome everyone. I believe it is prime time to start today's teaching. The first lecture will be delivered by our esteemed guest, Dr. Akash Thakar. My colleague Harshit will be introducing him shortly. Before we do that, a couple matters of practicality. Dr. Thakar opened himself to a brief Q&A session at the end of the lecture. So feel free to drop your questions and observations to him in the chat, which I enabled for this session. And also, right after the lecture, by all means, please hop over to the introduction session of the National Cyber Resilience Game. This is one of the most informative and fun parts of the IDCSS 22. And our deputy director here at HCSS will explain to you how the National Cyber Resilience Game works. The reason I'm emphasizing this is that the two sessions will take place back to back, and we want everyone to have streamlined and easy access to both of today's events. Now, Dr. Thakar, I'm really excited for your lecture. Thank you so much for taking your time to contribute to the Indo-Dutch Cybersecurity School this year. And I would like to yield the floor to my dear colleague Harshit, who will introduce you to the audience.
Yeah, so thank you, Adam. So we welcome Dr. Akash Thakar, who's a certified ethical hacker, computer hacking forensic investigator, and certified EC Council instructor. Having sound knowledge of digital forensics and VAPT, he has completed his PhD in forensic science and master's in forensic science from Gujarat University. He has taught various subjects to the students of undergraduate and postgraduate courses like computer forensics, network forensics, malware analysis, advanced digital forensics, memory forensics, etc. So he has led a lot of research in digital forensic investigation process and memory forensics. So we are very grateful to Dr. Akash who has agreed to take a session for our students. So now I request Dr. Akash to start his lecture. Thank you.
Yeah, thank you, Harshit, and for a brief introduction about me, and thank you, Adam, for inviting me and giving me this opportunity to share my knowledge with the students. So before I start, let me just share my screen. I hope my screen is visible.
Loud and clear, sir. It's visible.
Okay. Right. So as you are aware, today we'll discuss about Windows forensics and leveraging capabilities of open source tools, right? Because as we know, Windows is very widely used operating system amongst all other operating systems today we have in the market, right? So the contents that we are going to discuss today is why Windows forensics, why we should worry about Windows forensics, brief about crime scene management, then forensic imaging, why forensic imaging is so much important, what is the difference between imaging, cloning, copy, and then without wasting much time in theoretical part, we'll quickly move into the practicals, and I'll show you Windows forensic artifacts, how we can parse those artifacts, how we can analyze and interpret those artifacts. All of these things will be done with open source tools, right? Okay. So first, why Windows operating system? As you can see here, Windows operating system is being used by almost 73% of all the users of computer, right? Computer includes your servers and everything. Okay, so most of the users are using Windows operating system, right? After that, 21% around, I can say, people are using Mac OS, Chrome OS, Linux, and so on. right? So why we should worry about Windows, why we should focus on Windows artifacts, why we should focus on Windows forensics? So here is the reason, right? Because most of the people are, used to with the features of Windows. Even we can say professionals are also using Windows, even learners are also using Windows. Most of the persons are using Windows operating systems, right? Okay. So digital evidence collection process from computers. I'll not give much time into these slides where we'll discuss of theory. We'll mostly focus on the practicals. Right. So situation one, if monitor is on and work product is going on, right? So what we'll do? We'll capture the photo. We'll capture the screen or whatever is visible in our screen. We'll try to acquire memory in the running state, right? The standard procedure of digital forensic says whenever you find a system in the running state, first and foremost thing is to acquire RAM from the system, right? Because RAM can contain wealth of information which is not available in your hard disks, right? For example, running processes, right? What are the processes that were running into the system at the time of acquisition is only available if you acquire RAM. Okay, loaded DLLs, loaded drivers, network connections, all these things, even registry, all these things are all only available in your RAM, right? Okay. Second situation is if the monitor is on but screen is blank, either it is in the sleep mode or it is showing you screensaver or something like that. What you should do? You should not press any key, right? Instead of that, you just hover your mouse and try to wake up your screen, right? So that it will it will not change anything into the system, right? Let's say if you press any key, and when you press any key it can make changes into the system, into the suspected system, which is not acceptable, right? Which is not suggested, which is not recommended as a forensic investigator. Okay, so try to hover your mouse and try to wake up your computer. Okay, now let's imagine you reach to the crime scene, you have found that system is in the running state. How you will collect your evidence, how you will collect RAM from the running system, right? Because in the hard disk, in the dead condition, you remove that hard disk, send it to laboratory and start your imaging, right? But for RAM, it is not possible. It will not work like that. You cannot remove that RAM from the motherboard and send it to laboratory, right? RAM should be collected at the scene of crime only, and that should be collected using softwares, right? So there are certain softwares available by which you can acquire RAM from the system, right? For example, let me show you those some of the softwares, which is, let's say, a very famous tool available is FTK Imager, right? Access Data FTK Imager, which is widely used amongst forensic fraternity. So when you first open your Access Data FTK Imager, this will be the interface that you will find, right? So you go to File and click on Capture Memory. Okay, so when you click on Capture Memory, it will ask you the destination where you want to save this file. Okay, let's say we'll save it on my desktop. See, file name is already taken, memdump.mem. It will take that image file in the mem format, which can be passed using Volatility or Belkasoft or Magnet or with some other tools, but ultimately it will not be visible in clear text, or it will not be visible in some other tools, right? You have to use certain particular tools, forensic tools, to parse the details of this .mem file. Okay, even you can add your page file. Page file is nothing but the extended RAM, we can say, in a layman language, where the data which is not in current use, which is stored in RAM, will be taken and will be dumped in a portion of hard drive, which can be said as a page file, right? So from page file also you can get to know what are the processes that were running but are currently not running, right? So this is how you can acquire RAM using FTK Imager. Again, and as soon as you click on capture memory, it will be done. I'm not going to do that, otherwise it will take some time. Okay, see, what is the drawback with FTK Imager is it is not portable, right? Being a forensic investigator, our main motive is minimum contamination should be there in the suspected system, right? Because when you upload a tool, when you run a particular tool in the suspected system, it will make some changes into the RAM, right? But the minimum changes should be done, right? For example, if you use FTK Imager, it is not portable, that you have to install into the suspected system and then only you can run, right? Now just imagine when you install a tool how much changes it will make, right? There will be very big changes, which is not acceptable, which is not suggested, which is not recommended, right? So to avoid that particular condition, there are certain portable tools available for us, right? Portable means plug and play. You don't need to install that tool into the suspected system, right? You take take those tools into the pen drive or whatever USB device you have, plug in into the suspected system, run that executable, and you are done. Right? For example, here is the tool named as magnet RAM capture. Right, I'll double click on that. I'll run it with the admin privileges. Okay, so as soon as I open this magnet RAM capture, it will ask me where to save. I'll browse it. The basic recommendation is to save it into the same external drive, right? But for example, just for the demonstration, I'll save it on my desktop and I'll give it as sample. Now it will acquire this RAM in the .raw format, right? And I'll click on save. And as soon as I click on start button, it will start acquiring RAM from the system. As simple as that, right? Okay. There is another tool called Belkasoft Live RAM Capture. It has two options, whether it is 64-bit or 32-bit. Accordingly, I'll select my 64-bit and I'll run this RAM capture 64. Okay, here also the same option. See, by default, it will save this particular image file in the same path from where you are running this particular executable, right? And as soon as I click on capture, it will start acquiring RAM from the system. Again, as simple as that. You don't need any high technical knowledge to acquire RAM from the system. Okay. Now there is another tool called as dumpid, which is a command line utility. Right, a command line in the sense, what you need to do, it will ask you, are you sure you want to continue? As soon as you press Y, it will start acquiring memory. As soon as you press N, it will stop, right? And it will save this data in the same destination from where you are running this particular executable. As simple as that. Okay. Now coming back to our presentation, this is how you will acquire RAM if you find that system is in the running state, right? Before going for investigation, you should also know how to collect the evidence, how to seize the evidence, how to interpret the evidence, and then you can start your investigation. Okay. Now, other thing is the basic property of digital evidence is how it differs from other evidence is it can be exactly replicated. Your digital evidence can be duplicated, it can be replicated, so that analysis can be done on the duplicated one and original can be kept in the safe place. If you want to produce it into the court of law for further analysis or anything, it is possible, right? Most of the other evidences, let's say biological evidence or some other evidence, you cannot replicate it. Analysis should be done on the same evidence portion, right? So that is how digital evidence has that benefit for investigators. So there are three ways how you can replicate your evidence. One is copy. You can directly copy your evidence from source or you can say suspected drive to the destination one. You can imaging or you can clone your drive, right? So there are three concepts of doing this replication. One is copy, imaging and cloning. So what is the difference between these three things, right? So let me just open my whiteboard so that I can share it. I can just explain it in a very this manner. Okay, so this is your, let's say, hard drive. Sorry for my drawing, but you just consider it as a round, as a circle, and this is your hard drive. Okay. So this is your suspected hard drive, which is having 1 TB storage, and this is your destination hard drive, which is also having 1 TB storage. Right. Now what is happening in your image, your copy is, let's say out of this 1 TB, 500 GB data is occupied, right? Rest 500 GB is vacant. So when you copy your hard drive, only 500 GB data will be transferred to the destination. right? The rest 500 GB will not be transferred because it will copy only those data which is residing in your hard drive. It will not send any unallocated data. It will not send any slack space. Nothing will be sent. Okay. Now in the same scenario, you have, let's say, 500 GB data in your hard drive, suspected hard drive. Now out of this 500 GB, when you clone your hard drive, everything will be transferred, right? Everything will be transferred here. All your 500 GB. It is also been called as bit stream image, or it is also called as bit by bit image, right? Because you see, bit is the smallest allocation unit available in our hard drive, and in the cloning as well as imaging, every bit, every single bit will be transferred to destination, right? That is the similarity of imaging and cloning. But what is the difference? See, cloning will make a working copy. Cloning means, in a general term also, we can say cloning is the exact replica. Not a single dot, not a single sector is changed. Right? That is what cloning is all about. Right? In the cloning, this will not be changed. But in the imaging, it will make a archive copy. Right? Your data will be in the archived form. For example, your 500 GB data is stored, 500 GB is vacant, but still it will transfer entire 1 TB with unallocated space, right? So that you can recover your deleted data also, right? Make sure in the imaging as well as cloning. Okay, so how to create image? How we can create imaging of this particular system? See, forensically, we always prefer to do imaging over the cloning, right? You see, because cloning will make a working copy. You can just replace your suspected hard drive with the destination one, and you can boot your system with that particular duplicated hard drive, and you can preview everything as it were looking in the system, right? But there are chances that data can be tampered. One thing. Second thing, there are so many other evidences or other artifacts which is only possible to parse if your system is in the offline condition, or if it is in the archived form. If it is running in the running state, you cannot parse those details. For example, Windows registry, right? You cannot open registry files, or else, for example, there are $i30 file, or there are $log files or recycle bin files. So there are so many other artifacts which is only available if it is in the offline condition, right? That is the reason why we will always prefer imaging over the cloning, right? The same thing is written here. What is the difference between copy paste? What is the difference between cloning and what is imaging, right? You see, there is a small concept of write blocker that we should also understand. Write blocker is a kind of we can say device which is available here. You see, this is your write blocker device. Whenever you are trying to image your data in this suspected hard drive, that should be connected with the write blocker, and through that write blocker that should be connected to the system, right? Reason being, this will block the writing permissions into this hard drive, right? So you cannot write anything into this device. So when writing permissions is blocked, data integrity will be maintained, right? You can preview this content, you can still preview this content, but you cannot change anything, you cannot temper anything, you cannot delete anything, you cannot do anything into this hard drive. Modification is blocked, but reading permission, viewing permission is given, right? So that is the use of write blockers that we should keep in mind. Okay, how you can create imaging using FTK imager, which is widely used. There are some other hardware devices are also coming for imaging purpose, but let's focus on FTK imager, which is widely used by forensic fraternity. So you see, this is the interface of FTK imager. What we need to do, we'll create image file. You just go to file, option is given, create disk image. Okay. In the physical drive, it will identify my entire hard drive or devices which are connected to the system. For example, it will identify my drive 0, drive 1, drive 2, and so on, right? But if I select logical drive, what it will do, it will give volumes, C drive, D drive, E drive. It may be possible that in my hard drive I have various volumes, and I am interested in only a particular partition, so I can select my logical parts. Right, image file. See, this is a bit confusing for so many people that why we want to create an image of image file. Right, already we have an image file which is an offline file. Directly we can copy and paste it into the other destination. Why we need to create an image? Right, so the answer is to convert image file from one format to another format. You can use this option. For example, you have created image file in raw dd file format. Right, now you want to convert that raw dd into E01. That is possible with this image file option. Right, or even you want to convert one file format to any other file format, it is possible. Contents of a folder, if you are interested in only a particular folder or particular file which you want to create an image, that is possible. Or Femico devices, CD, DVDs and all these things. So just for the example, I'll select logical drive. Let's select C drive for the example. I'll select my destination. Now you see I have four options. Right, either I can select raw dd, or I can select smart, or I can select E01, or I can select AFF. Right, so what are the difference between these four files, four file formats? See, technically it is also called as containers. Right, they are the containers where all your data are being stored. Okay, so the basic difference between these four file formats are: raw is simple bit by bit copy of the hard drive without leaving or adding any single bit. Right, as we discussed, imaging is bit by bit copy. Right, this image is usually accompanied by a separate file which contains meta information about the image file, but raw file itself does not contain any metadata of your case or of your image file. Right, there will be a separate file which contains information, but raw file itself does not contain any metadata. Other drawback of raw is it is not having any compression. Right, so let's say if your suspected drive is having 1 TB data, 1 TB storage capacity, then destination file will also be of 1 TB. It will not use any compression. Right, even if your data stored is 500 GB, still your destination file will be 1 TB. Right, because it does not have any compression. Okay, but the benefit of raw is it can be converted in any of the format. Right, for example, if you want to convert raw into E01, it is possible. Okay, raw file format is widely used by almost every tool. Right, even non-forensic tools are also supporting raw file format. Right, whereas E01, which is a file of EWF family, that is called as evidence expert witness format, it is a proprietary file format of NCASE software, right, which is a commercial tool. Okay, now it contains information related to the acquisition process, investigator name, timestamp, everything, whatever you are typing during the imaging process, everything is been noted and everything is been stored. It will also calculate hash, or you can say checksum, after every 32 KB of the data. Right, you see, after every 32 KB of the data, hash value is been calculated, and at the end it will also give you the MD5 of your entire bitstream image. Now E01 will contain some compression. Right, so for example, if your hard drive is of 1 TB in containing 500 GB data, it will give you the destination file format of, let's say, 600 GB or 700 GB, depending on the size of data and so on. This will use compression. Right, okay. The third file format is AFF, or latest version of AFF is Advanced Forensic File Format. Right, it is not so popular amongst forensic experts or forensic fraternity, but believe me or not, in a near future, this file format will be used widely. Right, reason, this is open source file format. Right, second thing, it is not proprietary, it is open format. It also contains metadata. Any sort of data, any sort of image can be added into the AFF4 container, and comprehensively it can be analyzed. For example, as we saw earlier, for memory sample you will have .mem file. Right, for hard disk you will have .dd or .e01. For network artifacts you might have let's say pcap file. For mobile phones you will have some other file format. But AFF container is the open container where all sort of data can be included and analyzed comprehensively, right? So that is the major benefit of AFF for file format. Okay. So these are the options which will be given to you. I'll click on next. I can add anything, case number, evidence number, unique descriptions and everything. Okay, I'll add my destination on my desktop. Let's say image file name and so on. If I want to fragment my image file, that is also possible. If I don't, I can leave it. And I'll click on finish. And as soon as I click on start, it will start imaging process, right? But I'm not going to do that. Okay. Another option which is given here is custom content sources, right? In FTK Imager, I can use custom content imaging option also, right? For example, you have 1 TB hard drive, out of which you think that only 1 GB data is related to the case. Rest is not relevant to the case, right? So there is no meaning to image entire 1 TB. Okay, so what you can do manually, you can add those files into this custom content sources and you can image those files, right? That is FTK Imager. But the better way to image these things is using Avimetry tool, right? Which is commercial tool. But you see, in the Avimetry tool, it will give you this option that is also called as non-linear partial imaging, right? This is also called as non-linear partial imaging. Okay, which will give you the option based on the artifacts you can create an image, right? For example, you are interested in only, let's say, Windows registry files, or you are interested in only documents, or you are interested in only multimedia files, right? So why to do imaging of your documents? If you are investigating some child pornography crime, why to image your documents? Why to image your executables? Why to image DLLs? Why to image system files? There is no meaning, right? So in such conditions, you can select only those files which are related to the case. Based on the context of case, you can select those files, you can image and you can investigate those cases, right? That is the major benefit of this Avimetry tool. This Avimetry tool will also create image in AFF for file format, right? Okay. Now let's get back to our job. Let's get back to our main topic, that is forensic artifacts of Windows operating system, right? Within the time limit, I'll try to cover most of the artifacts as I can. Very first is Windows registry, right? So as we know, Windows registry is a database of information. It includes settings, options, and other values of softwares and hardwares which are installed in all sort of operating system, all sort of Microsoft Windows operating systems, right? Everything which is installed into the system, including software and hardware, whatever users are doing, whatever users are changing into the system, everything is been stored in Windows registry, right? When we'll first open Windows registry, how we can open Windows registry? We just type regedit, right? When we'll open regedit, it will open Windows registry into the system, right? So when we open Windows registry, it will give us these 5 registry hives, right? Which is called as H key. H key stands for registry hive. Okay. Now what does those registry hive means? First is HKey classes root, or it is also called as HKCR. You see, based how your computer knows that I need to open this JPG file in Windows Photo Viewer, or how your computer knows that I need to parse this MP4 file in VLC Media Player or Windows Media Player, based on the extensions, right? As well as based on this registry key, right? It describes all types, file extensions and object linking and embedding options, right? Here you will find that which file will open in which software, right? For example, .docx file will open in Microsoft Word by default, right? So based on this particular registry key. Then we have HKey current user. It will give us the details of currently logged in user, right? For example, in a computer, in a shared computer, there are 5 users who can be logged in into the system, right? So being a forensic investigator, you have identified that yes, this computer has involved into the crime, but who was the user, right? Out of 5, who was the particular person who has involved into this particular crime? So that can be identified from H key current user, right? It will give us the details about user who is currently logged in. Okay, H key LM, or we can say H key local machine, which is widely used by most of the system settings and most of the user programs, right? Whenever you install any hardware, any software, any information which is related to the software, hardware and system will be stored by H key local machine, right? This key and its subkeys are the most frequent areas which is been viewed and edited by the user in Windows registry. Then we have HKU, or we can say HKey users, which contains information about all the users. It is a generic information of each and every user who is ever logged in into the system, right? Both generic as well as user specific information. And HKey current config, it will give you the details about configurations of hardware which are attached to the computer, right? So these are the 5 registry hives which you can see here also in regedit. Okay. So what is the forensic importance? So you see, registry is a giant database, as we know, which contains information regarding operating system functions. It also stores programs and settings for the program. Okay, now you see, we can open regedit in a running state, right? But let's say you have image file. How you can get it? If you have only image, if your computer, your suspected hard drive is not in the running state, you cannot turn it on. How you can analyze those registry files? You see, it will be available in this path, C Windows System 32 config, right? So let me just go to that path. It will be available at this C Windows 32 and config. Right, so this is the path where you will find your registry files. Okay. There are different registry files named as default, SAM, security, software and system. These are the registry files which are widely used and can be analyzed for forensic purpose. Right, these are most common and important registry files, and all of them registry files will be available at this path, C Windows System 32 config. Even some auto backup of these registry files are also been stored in regback folder. Okay. Now you see, there is a user specific hive which is associated with HKey CU, or it is also called as HKey current user, which is located in C users, whatever username of your system is, and it will be named as ntuser.det, right? So C users username, and here you should have that ntuser.det, but you have to check hidden items as well as, right? So you see, here is your ntuser.dat file, right? This is nothing but the user specific registry file. Okay. Now, what is the forensic importance? What are the forensic artifacts? I have listed down some of the artifacts because every artifact cannot be shown into this particular time frame, right? So very first is recent docs, right? So you see, it will be available at this path, HKey users, HKey current users, or in the offline condition, it will be ntuser.det, software, Microsoft Windows current version and Explorer, right? So let me open my regedit and go to that path. HKey current user, Microsoft Windows current version, okay, HKey current user, sorry, software, Microsoft Windows current version, and here I should have Explorer. and within that explorer I'll have recent docs, right? So you see it has these recent doc applications, but can you interpret it? Sometimes you will find the name, but it is difficult to interpret, right? It will also give you the details about particular file type, right? So you see here I have JPG and JPEG, right? If I want to know what are the JPGs that were open into the system, I can get it from this path, right? But it is not interpretable. Here MRU list is also given. MRU is most recently used, right? MRU list is also given, which is called as most recently used. Okay, but how to parse these files, how to parse these details? Using a tool which has been developed by a gentleman named as Eric Zimmerman, right? You can get this tool from Eric Zimmerman's website named as Registry Explorer, right? Registry Explorer is a very good tool which has been developed by Eric Zimmerman, which can be used to parse the details of Windows registry, right? So let me just open that particular tool. Let's wait for a moment. Okay, so I can load my registry hives, right? So I'll go to my C drive and I'll load my ntuser.det. Or else I can open my FTK imager and grab that registry file, right? Okay, so I'll load that particular C drive. I'll grab that ntuser.dat in my desktop in the offline condition so that I can get those details, right? Here you see it has not parsed because it is in the running state, right? As I told you, what is the benefit of imaging is it will be in the offline condition. If it is in the running state, you see it has not been parsed, right? So I'll go to that path, users, username, and I'll get that ntuser.dat. I'll export it on my desktop. Now I'll load that file from the desktop. Right, somewhere it should be, yeah, that is ntuser.dat. Okay. Now I'll again go to the same path, softwares, Microsoft, Windows, current version, and it should be under Explorer. Right, under that I'll have my recent docs key. Right, so here is your recent docs. Based on the extensions also I can get it. You see, if I open JPG, let me just zoom it. You see, I can see what are the JPGs that were opened with their name, screenshot, PhD, notification, and so many things. With their MRU position is most recently used position. It is also organized in chronological orders. But here I can get to know what are the files, what are the JPG files that were open into the system at any point of time. Right? Even sometimes you will get the timestamp also. Right? Let's say if I'm interested in .docx file. Right? So here I'll get my docx files which are open into this system. Right? If I want comprehensively, I'll click on recent docs and it will give me all these things. You see sample.raw and so many things. Right? So this is how you can parse the details from Windows registry. Okay. Other thing is run MRU. Other key is run MRU, which is also available in the same path. I'll go to run MRU. You see it has only one entry. It's tpm.msc. Right. Run MRU means whatever you are typing in this Windows run key, right, it will be stored and it will be given here. Okay. There is another artifact called as typed paths, right, which is also available in the same registry key. What you see, I don't have any entry because I have not typed any path, right? But whatever path you are typing in your path bar of Windows Explorer, whatever you are typing here, it will be available, right? So that is how you can leverage the information about Windows registry from this Reg Explorer, right? Okay, I hope it is clear. Okay. I have also added some screenshots, right? Another artifact is called as prefetch, right? Prefetch means, you see, the name itself suggests it has been fetched before you run that application, right? So at any point of time when you run a particular application, it will create its prefetch, right? And when you reopen that particular application or that executable, it will be open in a very faster manner. Why? Reason being, it has been pre-fetched by your operating system, right? So the same thing can be leveraged by forensic investigators to identify what are the executables that were run by we can say a person into this system, right? So there is a tool called Win Prefetch View from the Nearsoft. Nearsoft is nothing but a utility which is being used by forensic investigators. So we can use Win Prefetch View. Right, I'll run it with the admin privileges. And let's wait. It will not take much time. Within a seconds or two, it should give us the result. Right. So you see, here are the files which were executed by user. You see, it has recently identified the application which we use, Registry Explorer. Right. It has identified that we used regedit, we used dumpit, we used all these tools. You remember, right? So it has identified those executables which were run by the user into this system with their creation time, with their modification time, with the process path, and so on. Even it will give you the run count also. How many times this application was run into the system, right? Along with the last time run as well as last 8 run time of this application into the system. Your prefetch stores information about last 8 run time into this system, but run count can be 16, 22, 14, whatever. Right. See why it is important. Why prefetch is important. Let's say there are some portable tools available. Right. For example, this is the portable tool which we used. Right. Dump it. Right. This was used from the external drive. Right. Now you see, being an investigator, you cannot recover this drive from the suspected from the crime scene, and still you want to know what are the applications that were run into the system, because this is portable, this is not installed. Still you will get it from the prefetch, right? So that is the benefit of in prefetch. Okay, so I have also added those screenshots. Shellbacks, see, shellback is whenever you customize your folder, right? For example, your preview of the we can say folder is being changed, so that customization is stored in your shellbacks, right? So why forensically it is important? Because sometimes when you access any folder from the external drive, right, and you want to prove that yes, this folder was executed at some point of time into the suspected system, shellback can be used, right? So how to parse those shellbacks? There is a tool called Shellback Explorer, which is also developed by Eric Zimmerman, right? Okay, so let me just open this application, Shellback Explorer. Okay, so this is the interface of Shellback Explorer. You just go to file and load active registry files, or you can load offline registry files also. It's totally up to you, right? So here you see, in my system, let's say I have only D drive, C and D drive. But if you can identify that this was opened from external drive, this was identified from E drive or F drive or somewhere, you see it has been opened from I drive, contents of I drive. Right? So I can prove that these were the files which were executed from external drive because I do not have any I drive into the system. Right? So this can be useful for proving that thing. Okay. Right. Volume shadow copy. You see, it is a kind of service of Windows operating system which is similar to restore point. Right. It will create, we can say, a copy of your operating system as if it were before 1 week or before 10 days or something like that. It is a kind of snapshot of your operating system. Right. So if you want to know what are the files and folders available into the system before 1 week and it is not available now or vice versa, you can do it with volume shadow copy. Right. So there is a tool called as shadow copy view which is available to parse these details. Right. Which is in the Nearsoft again. Right. So I'll go to Nearsoft and I'll open that file called shadow copy view. Okay, so you see in my system I have three shadow copies available, which was calculated on 3rd of November today, 1st November and 29th October. Right, so if I want to know what are the files and folders available on 29th, I can see here, let's say on my desktop, what are the files and folders available. I'll locate my desktop. Or let's say if I locate my downloads, you see these are the files available, but currently I have multiple files available. I have many files which are available. You see team setup, which was not available on that day. Right? So definitely you can prove that. Okay. USB devices. You see, USB devices can be parsed either manually or automatically. Right? So these are the registry keys from where you can parse those details manually, or else you can parse those details automatically with the tool named as USB Deep View. You see that is also available in Nearsoft. You just open this tool, run it with admin privileges, and it will give you all the USB devices which were executed, which were opened by user, which were connected by any user into the system with their serial number. Right? You see, it has device name, description, excuse me, whether it is currently connected or not, what was the drive letter which was assigned with their serial number, created when last plugin. See, created means when it was first plugin, right? And last plugin is when last it was connected to the system, and so on. Vendor ID, product ID, which is also called as VID and PID, and everything. Right? So this can also be used to prove that yes, this device was connected into the system at this particular time. Okay. We have link files. You see, link files are those files which are also called as shortcut files. Whenever you execute any program, any file or any, let's say, folder, it will create its own link file, right, which is available into this path, which is C users username app data roaming Microsoft Windows. See, those things are written into this PPT, which will be shared. So you see, these all are the shortcut files. You see, these are shortcut files, but at any point of time, these files were open. So not even that, you can get multiple details like original path. You can get original path of the file, right? Original file of the targeted file, right? Original file as well as shortcut file, timestamp, size of the original file, attributes which are associated, series, system name, volume name. Even you can get sometimes MAC address also, whether the file is located in the local system or if it is accessed from remote access, that is also possible, right? So that is the benefit of link files. Okay. there is jump lists, right? Jump list is the feature of Windows 7. Jump list is also called as taskbar feature of Windows operating system. You see, when I right click on any of the program, it will give me the recently opened files within that application, right? Your prefetch will give you the generalized applications, generalized executables, whereas this jump list will give me the files which were opened in particular software, right? For example, here I have opened these PPTs, right? If I go to my Google Chrome and right click, these are the files which were open. These were the tabs which are open into this system. If I right click on, let's say, Reg Explorer or my Explorer, you will find these are the folders which were recently opened by my system. So these details have been stored in jump lists, right? So how to parse those jump lists? You see, there is a tool in Nearsoft available which is called as jump list view. So I'll go to this jump list view and it will give me the details. Let's wait for a moment. Right, so you see, these are the files with their icons. Also you can get to know what are the files which were open into the system with their path, with their record time, creation time, modification time, and everything. Right. Timestamp analysis. You see, in your MFT is also called as master file table, which stores timestamp in two different attributes. One is standard information and second one is file name attribute, right? The standard information as well as file name. Now, there are so many ways by which you can manipulate and temper the timestamp of any file, right? Which is also called as timestamp, or it is also called as anti-forensic techniques, right? Now, when you change the timestamp, that will be changed only in $SI attribute, right? But $FN, or we can say file name attribute, cannot be changed, right? $file name attribute cannot be changed by user, right? Okay. So you see, this is the example. I have this original file and this is the tempered file. This is manipulated timestamp, right? Some random numbers I have given. So how to identify? You just use FTK imager to grab that MFT and load that MFT in this MFT Explorer, right? You see, this is the MFT Explorer where you will get the sample.docx, and here you see $SI and $FN, right? $SI file and $FN attribute. So this will be the tempered timestamp. This is the original timestamp. You see, again, this is the tempered timestamp. This is the original timestamp, right? And you see, it is also identified that whether it is time stamped or not. It has been ticked. It says yes, it is time stamped. So I hope I have wind up my session within the given time. If there is any questions, I'll be more than happy to answer that.
Thank you so much for your expert lecture, sir. There seems to be some interference. Can you mute yourself while I'm moderating the questions? Great. Thank you. I think I'm speaking on behalf of all our students when I say that your knowledge of cyber forensics is really impressive expertise. A lot of people are saying in the chat that they loved your lecture, and so did I. Very enlightening indeed. I would like to start with a question from Birendra. He would like to know what the difference is between cloning and imaging, and also where's the ragback folder?
See, the difference between cloning and imaging is cloning will be the working copy of your original hard drive, right? Same as your original hard drive, you can replace your clone hard drive with the original one and you can boot your system, right? So basic difference, I must say, you are creating a bootable pen drive, right? During that bootable pen drive, you are using certain tools to create a bootable pen drive, right? You cannot directly copy all the contents of your Windows operating system and paste it in your pen drive. It will not work, right? Why? Because it has to create MBR, it has to create bootloader, it has to create MFT and so many things. So when you clone your hard drive, everything will be generated. Your MBR will be generated, and based on that, you can boot your operating system. But imaging will be the offline copy, right? The benefit of offline is you can parse the details from system files, right? When your system is on, you cannot parse those details, right? When your computer is in the offline condition, you can parse those details, and based on that you can investigate those artifacts, as we were discussing into this session, right? About the ratchback folder, it is available into the same path, C Windows System 32 config, right? There you will get that ratchback folder.
Thank you, sir. Mr. Reddy would like to know, how can I get the user details which was connected using VirtualBox, such as Windows, Kali Linux, etc.?
See, when user has used virtual machine, there will be a .vmem file which has been created for memory, and .vdi file which is created for that hard drive, right? Some VHD files are also created based on the virtualization system you are using, right? So you can grab that entire virtual hard drive and you can investigate it as a separate operating system, right? Because it is not the part of your host machine, although it is virtual hard drive, but it is not actual part of your host machine, right? So you can grab that virtual hard drive and investigate it as a separate operating system.
Thank you, sir. Praveen would like to know the following. Nice session, sir. I have understood that we can get details about files that were accessed, but can you please explain how to get files, images/videos that were executed from external pen drives or SSD?
See, in the prefetch, as I told you, it will give you the executable programs, irrespective of its directory or irrespective of its path, right? If that executable was executed from external drive, then also it will be stored in prefetch. In terms of files and images and videos, that will be stored in link files, right? Again, irrespective of whether the data is stored in your local hard drive or if it is been accessed from your external drive, the path will be mentioned, right? For example, your path is showing that it was run from E drive and your computer has only C and D drive. Definitely you can say it was run from external drive, right? So using those artifacts, prefetch and we can say this link files, you can get to know whether the file and executable was run from local system or from external drive.
Thank you, sir. A number of our students would like to know if you would be okay with sharing your PowerPoint after the lecture.
Yeah, definitely. I'll mail it to you on the same mail where you have sent me this invitation. No?
Fantastic. Thank you, sir. And the next question. Yes, so Panchami would like to know whether you have any good recommendations for websites or books where the students can learn more about cyber forensics.
There are lots and lots of we can say YouTube channels are available. Even you can go for certain blogs also, which you can refer for we can say learning the digital forensics and incident response. Few YouTube channels I can suggest is one of them is DFIR Science. Second one is 13 Cubed, which is one of my also favorite. And in terms of books, there is a book named as Practical Windows Forensics, right, which shows all the tools with their practical examples. So the book I'll recommend is the Practical Windows Forensics.
Thank you very much, sir. And perhaps we have time for one final question from Archana. Sir, is it possible to track or get files that were used from cloud-based drives? And if so, how?
See, cloud-based drive means if it was accessed from your local system from cloud, as we told you in the link files, it is also possible to identify whether it was local or it was remote. If it was accessed from remote desktop connection, then also it will give you the connection. It will give you that yes, this was accessed from remote drive as well as with the IP address sometime. Right. Sometimes we will also get the IP address of the system from where this system was connected using RDP, and you can get to know that yes, this file was accessed from this remote drive.
Thank you, sir. Thank you so much for the informative and enlightening session. All of our students are expressing their gratitude in the chat. I believe all of us had a lot to learn today. I would like to thank you for your contribution to the IDCSS 22. I believe you contributed a lot to fostering a new generation of young cyber forensics professionals. And to that, I would like to express the gratitude of the Hague Center for Strategic Studies as well. You were really generous with your time, and we really appreciate that. Now, before ending this Teams meeting, I would like to remind everyone that
Adam, I think you're not audible. Dr. Akash, is Adam audible or is the issue with me?
No, he's not audible to me also.
Okay, so I'll just finish this. So initially, thank you, Dr. Akash.